So consider the effect of two perpendicular forces acting on a particle P. So you can see these two forces here, and they are perpendicular because this here is a right angle, yeah? 90 degrees, so they're going in perpendicular directions, right angle to each other, in other words. So you've got these two forces, one pulling horizontally and one pulling vertically. So what's the overall effect? That's what it's saying here, isn't it? Find the magnitude and direction of the resultant force. What's the overall effect of this? Well, if you think about it, if there's a force pulling on an object in this direction, the object is going to want to go in this direction, isn't it? But if you've also got an additional force pulling upwards, okay, it's also want to go up as well. So the combination of the two forces applied to it will make it go sort of in that direction there, yeah? Okay, so the resultant effect, and that's literally what we call it the force R, which is the resultant, the overall effect, will sort of be going that way, which is a combination of these two. Now, what we can do is find the magnitude and direction of this resultant force. In other words, we can find the size, okay, that's what it means by magnitude. We can see how big this resultant force is, okay, the overall effect of these two, okay. And we can also get the direction. In other words, we can get what that angle is there, okay, call it theta. We can work out what that is. Now, another way of thinking of this setup here is appreciating that we're going across 8 and up 15, okay, because it is being pulled 8 in the horizontal direction and being pulled 15 in the vertical direction. So you can think of it like coordinates, across 8 and up 15. We can go in that order and we can create a triangle, okay, so across 8 and up 15, okay, and 15 obviously is almost double 8, so you know, if you wanted to, you could even double the line to get some perspective, alright, don't have to, but that might help you see things. So it's like going across 8 and up 15, and you end up here. So that will be my resultant effect, okay, in other words, taking me from here along this line. That's the resultant effect, that's the path that it ends up taking, okay. So we can use this triangle setup to work out R, and we can also work out theta. To work out R, okay, think about what we've got here. Well, it's a right angle triangle, isn't it? Because you're going across then up. So we can use Pythagoras' theorem. So remember with Pythagoras, we have this squared, okay, the hypotenuse of squared is equal to the square of the other two sides added together. So 8 squared add 15 squared. And what you can do then, of course, I mean, you could work that out on your calculator, and then to get R, you take the square over and the square root. So you can do all that in one go, right? That's what we tend to do. So if you do that on your calculator, it'll come out as exactly 17. So the overall resultant force will be 17. Now to work out the direction, it's just that angle, isn't it, to the horizontal. Well, we can think about trigonometry, SOHCAHTOA. So remember with SOHCAHTOA, hypotenuse is that side, alright? Opposite the angle here, and then adjacent then here next to the angles, okay? So to work out the angle theta, I could just use these two, couldn't I? O and A, because I know O, know A, I know H as well, I know that's 17 now, but to be honest, I'll just use these two here, because these are the two that are given to me. So O and A, so with SOHCAHTOA, you know where O and A appear, okay, it's always there with a tan, so we usually use tan when it comes to working out the angle. So tan theta will equal to, follow that order, O over A, so 15 over 8. So then to get theta, you do tan to the minus 1, or 15 over 8. So my calculator, in degree mode, 15 over 8, tan of that. It comes out to be 61.9 degrees, 1 decimal place. So in other words, the direction, it goes in a direction of 61.9 degrees to the horizontal. Okay, and to be honest, you'd expect it to go at quite a steep angle, because if you think about it, yeah, it's 8 newtons being pulled this way, but it's 15 newtons being pulled in the vertical direction, or almost twice the force going vertically, so that angle is going to be a lot bigger, isn't it? Okay, so we've got our angle and we've got our resultant force.